Hello everyone, welcome back to my channel. In this video, we are going to discuss about which of the following molecules shows positive iodoform test. Now, basically, what is iodoform test? Iodoform test is basically shown by the molecules of the form of this. Now, this is what this is our methyl ketone. This molecule is methyl ketone. So, if we have any methyl ketone molecule, it definitely shows us the positive iodoform test. That means here, the second last carbon must contain the carbonyl group in the molecule, and the last carbon should be in the form of methyl group. This is the meaning of methyl ketone. Or any molecule which is in the form of secondary alcohol, right? That is, the second last carbon should contain the OH group, and the last carbon should be in the form of CH3 molecule. Now, one thing is easy to understand that yes, carbonyl compounds like the above one, like the methyl ketone one, definitely shows us the positive iodoform test. But what about the second one? Second molecule is alcohol. So basically, what happens in the iodoform test, the reagent which we use is NaOH plus I2. That is a strong base in the presence of iodine. Sometimes the reagent is written like this, and sometimes the reagent is also written like this, NaOI. Right? Now in NaOI, basically, what are the ions? The ions which we have is Na plus and OI minus. Now, definitely, oxygen is a more electronegative element as compared to iodine. So, and we know oxygen generally exhibits -2 charge, but the overall OI has a charge of -1. That means here oxygen has -2, iodine has +1. That's why overall it is what? -1. Now, iodine being an electronegative element having the positive charge is relatively less stable. So, what it will happen? It will try to acquire the zero charge or negative charge by gaining the electron. That means this I plus will undergo reduction. Now, because it will undergo reduction, it will act as what? It will act as oxidizing agent. So that means whenever we have this molecule, the second one, and we have the reagent like NaOI or NaOH plus I2, it will do the oxidation of 2-degree alcohol. And we know the 2-degree alcohol or secondary alcohol easily oxidized to ketone. And in this way, we again got the methyl ketone form. And hence the reaction is easy to occur. Now, in these molecules which are given to us, which of the following molecule shows the positive iodoform test we need to find? If you look at the first one, now the first molecule has the structure which we have just discussed in the case of second molecule, this one, right? The second last carbon having OH molecule and the terminal CH3 group. So yes, it shows. What about this second one? Now in the second molecule, if you see, in second molecule we have an active methylene group. Now what is active methylene group? Just a second. What I'm talking about is active methylene group. Basically, methylene is CH2 molecule, right? CH2, like this. Now here this CH2 part, this is active in nature. Active because here the hydrogens attached is highly acidic in nature. Here the hydrogen attached is highly acidic in nature, right? Because if you remove the hydrogen from here, what will happen? If you remove hydrogen from here in the form of H plus, it retains a negative charge, and this negative charge is easily stabilized by conjugation from both sides by carbonyl groups. Both sides we have the carbonyl groups which are a strong electron withdrawing groups, and they will easily stabilize the conjugate base formed at the methylene site, right? So here also this group also shows a good positive iodoform test. Third one also, if you see here, we have the CH3 molecule, right, methyl group, and this is methyl ketone form. It also shows the positive iodoform test. Next one is lactic acid. Basically, lactic acid is what? Lactic acid molecule is like this. This is our form of lactic acid molecule. So what is it? It is alpha hydroxy acid, right? This molecule is basically alpha hydroxy carboxylic acid. And what kind of carboxylic acid is this one? Propanoic acid, right? With respect to COH group, this carbon, this is alpha carbon, right? Now here also, if you look at the carbon, the one which is, just a second, right, the one which is in black color, this carbon and this molecule, this carbon, here it is active with CH3 group, and here we have the OH group. Now again, upon the oxidation, what will happen? This carbon containing OH will turn into C double bond O, and we have the CH3 part here. So again, this is what? This is methyl ketone part, right? Upon oxidation. So yes, this molecule also shows the positive iodoform test. We can again say. So lactic acid also shows. Ethanol, if we talk about, ethanol is what? CH3, CH2OH. Now, ethanol upon oxidation, as I've told you, that the reagent which we use is a mild oxidizing agent, so it can easily oxidize 1 degree alcohol into aldehyde, 2 degree alcohol into ketone. So it will oxidize this ethanol into ethanol, this one. So again, if you look at the ethanol, we have the active methylene group, right? Methyl ketone group, sorry. So yes, it will also show the positive iodoform test. Next one is chloral. Now, chloral molecule is basically this one, CCl3, C double bond OH, right? Now, here if you use the reagent NaOH in the presence of I2, this OH minus ion will attack the electrophilic carbon here. The negative charge goes to the oxygen, or we can say the pi bond goes to the oxygen. And what do we obtain? We obtain CCl3, C, O minus, H, and here comes the OH. Then this negative charge on the oxygen is unstable, it will come back and here releases the CCl3 minus. So what do we obtain? We will obtain CCl3 minus along with H C double bond O OH, that is formic acid. Now because the medium is basic in nature, what will happen? The CCl3 minus will take away H plus ion from the formic acid and it will form CHCl3 along with formate ion, right? Now, important thing is in this molecule, why do we have released CCl3 minus or CCl3 as a good living group? Because the negative charge will come on the carbon and it will be easily stabilized by back bonding in the case of chlorine atoms because they contain the d orbital, empty d orbital, right? So the negative charge on this carbon easily oxidized by the back bonding. That's why it's a good living group. Now the point is this molecule also shows the reaction, but it will not show you the positive iodoform test. Why? Because here the outcome which we are obtaining is the chloroform. This is where the climax comes, right? Had it been the iodoform is basically what iodoform is CHI3. It is a yellow colored compound, but the chloroform it is colorless in nature. Now, because it is colorless in nature, we will not be able to identify whether it is being released or not at all. But if it is iodoform, the appearance of yellow color will give you the identification that yes, the reaction has taken place and the iodoform is formed, right? That is why the reaction will definitely occur, but there will be no any physical identification or visual identification in this case. That is why chloral will not be able to give the test. Next, when it comes to PHC double bond of CH2I, here also we have the a kind of active methylene site. Here, in a way, already one iodine is attached, but still it will give you the reaction. This will also show the test. In the next molecule, again we have the methyl ketone site, which will also give you the reaction. The last one, CH3NO2, doesn't have the doesn't have either methyl ketone or doesn't have either the hydroxide containing style, right? So it will not show you the positive iodoform test. So how many molecules are there? We have total of 7 molecules which will show you the positive iodoform test. And which among those are there? You have easily seen and you have understood how they are showing it, right? So I hope you understood this positive iodoform test or the concept of iodoform test in this video. I hope you understood it properly. In the coming lectures, we will bring you more questions based upon the identification of the tests and the type of molecules which shows different type of these tests, right? So to watch those videos, stay tuned with this channel. Keep spreading the love. Stay tuned. Happy. Thank you.